Called titled Crystext AI-powered crystal structure generation. This project is developed by our team Manish Charandeep, Singh Gautam, and Sharan Raj. In this project, we explore how artificial intelligence can be used to generate crystal structure directly from natural language description. The main idea of our project comes from recent research in AI and material science. Traditionally, predicting crystal structures is a very complex and computational expensive process. It requires high performance computing and a lot of time. This idea is instead of using heavy calculations, we use fine tuned large language models to generate crystal structures directly from text. For example, if a user gives a description like chemical composition and space group, the model can generate a valid crystal structure. This makes the process much faster and scalable. Current materials discover methods depends on high throughout the screening and first principles calculation. These methods consume a lot of computational resources and are time consuming. Also, generative AI models face difficulty handles discrete atom types, continuous 3D positions, crystal symmetry constraints. Because of these challenges, it becomes difficult to generate accurate crystal structures efficiently. So our project aims to solve these problems using AI-based approaches. And there are many types of AI are used in. Now let's look the scope of our project. Generating crystal structures from text input using fine-tuned models like LLaMA and Mistral 7B. Output generation in crystal info CIF format, applying reinforcement learning techniques, validation using MP20 dataset. Out of the scope, real-time materials synthesize multitasking mode for and methodology supervised fine-tuning. We fine-tune pre-trained large language models using method called QLoRA. This helps the method learn how to generate crystal structures in CIF format based on the text input. Reinforcement learning. We use method like GRPO, which stands for Group Relative Policy Optimization. This improves the quality of generated structure by giving rewards based on accuracy. Validation framework, we validate the generated structures using a tool called Pigmentgen. It checks lattice parameters, atomic positions, angles. This ensures that generated structures are scientifically valid. Uh, this structure of validation framework, we validate the generated structures using a tool called Pigmentgen. It checks lattice parameters, atomic position, angles. Crystext system reinforcement learning. We used a method called GRPO, which stands for Group Relative Policy Optimization. This improves the quality of generated structures by giving rewards based on the accuracy we give on the project, which is based on main reinforcement learning. Expected output. By the end of this project, we aim to demonstrate that text-driven crystal structure generation is possible and scalable. By combining supervised learning and reinforcement learning, we can achieve high structural accuracy. This approach can significantly speed up materials discovery and open new possibilities in artificial intelligence driven science. So, expected output would be vary based on the input we given by the main artificial intelligence tool, which is based on the main process which is involved in the project. We are mainly based on the Crystext or crystal structure generation, which is possible and also scalable. By combining supervised learning and reinforcement learning, we can achieve high structural accuracy so that our expected output is up to 99% composition satisfiable and 87% structure match rate. And also it vary by many things based on the artificial intelligence driven science which is installed in the project which is given. By the end of the project, we will have demonstrated a scalable paradigm for text-driven crystal structure generation, establishing the both supervised fine-tuning and reinforcement learning enable accelerated materials discovery with a high structural validity. Technical implementations are also involved in the datasets we have taken and group relative policy optimization and large language models and QLoRA. Thank you.